Section 9.1 is about multiplying and dividing rational expressions. A rational expression is a ratio of two polynomial expressions. Here you see an example of that. The numerator is a polynomial, and so is the denominator. Now when you simplify those, you want to look for factors that will cancel from the top and the bottom. Now remember, you can only cancel things that are factors. So if you look at this binomial factor of x minus 5, there's also a binomial factor of x minus 5 on the bottom. And because those are factors, you can cancel them. So on top you'll be left with a 2x, on the bottom x squared minus 1. Now you're going to want to resist the urge to cancel this x and this x, because those are not factors. The top one is, but the bottom one is connected to a minus 1, therefore it's not a factor, and therefore they can't be canceled. So this is how you would simplify that rational expression. Then the second question here says, under what condition is the expression undefined? So we're going to go back to the fraction, and remember you cannot have a 0 on the bottom of a fraction. So all I care about right now is the denominator of this fraction. I don't really care what the numerator is. What I want to find is where the denominator will equal 0. So what I'm going to do is take the denominator and set all the factors equal to 0. And try to find the values that will create zeros in the denominator. Well, here I can just add 5 to both sides, so x equals 5. This one I can solve two ways. Either I can add 1 and then take the square root, or I could factor it, because it is a difference of squares. And then I can set each one of those groups equal to 0 using the zero product property. So x equals negative 1 and x equals positive 1. So under what conditions will the expression be undefined? It's undefined when x is 5, it's undefined when x is negative 1, and it's undefined when x is 1, because any of those values will create a 0 in the denominator. In this example, we want to find the values that will make this rational expression undefined. So once again, I want to know where the denominator equals 0. So I'm trying to find out what values for x could be plugged in the denominator to equal 0. Well, before I do that, I have to factor this to break it up into factors. Well, this is a trinomial. You can factor using the diamond. Two factors of 12 that add to be 7 are x plus 4 and x plus 3. Zero product property. So by solving this, we find out that if x is negative 4 or if x is negative 3, that will create a 0 in my denominator. Therefore, this function is not defined at negative 4 and at negative 3. Here we're asked to simplify a rational expression. That means we want to find factors on the top that are also on the bottom that I can cancel. You might be tempted to cancel the w's and the z's right now, but you can't because they're not factors. They're parts of a binomial, so you can't cross off these z's or these w's. You can't do that. Instead, you're going to have to factor the numerator and the denominator and then look for things that cancel. Well, on the top, I can factor out a GCF of z squared, leaving a w minus 1. And on the bottom, I can factor out z cubed, leaving 1 minus w. Now I'm going to cancel these z's, but I want to look at this w minus 1 and this 1 minus w. Those are pretty close. I mean, they almost look like they should cancel. It's just that the numerator is positive w and negative 1, and the denominator is positive 1 and negative w. So I want to show you one way that you can simplify that, and that's by pulling out a negative 1. So I'm going to take this top part and I'm going to pull a negative 1 out, and then I'm going to change the order. I'm going to make the w negative and the 1 positive. So I'm going to rewrite it as 1 minus w. So what I've done is I've taken the negative 1 out and then changed this binomial so that it matched the one on the bottom, and now I can cancel it. As far as the z's go, I can cancel 2 of them here and 1 of them there, leaving a negative 1 over z. You could write that as negative 1 over z. Either way is fine. But this idea of pulling out a negative 1, to get two binomials to match is a useful tool. Here we have some expressions to simplify, and I want to remind you that when you're multiplying, it's okay to do cross-canceling or up and down canceling as long as there's only multiplication involved here. as I see this expression, I notice a couple things will cancel, like the 5 and the 15 will cancel, leaving a 3. I notice the 4 and the 16 will cancel, leaving a 4. I see one a on top and then an a cubed on the bottom, leaving me a squared on the bottom, and then one of the b's on the bottom and the top will cancel. So I'm ending up with a 3b on top and a 4a squared on the bottom. Now if you're going to do it this way when you cross things off, you just have to be careful that when you cross things off you don't forget something. Let's do the same with this one. I would suggest you pause the video, try to do this one the same way I did it, and then come back and see what the answer is. So here the 5 and the 15 will cancel with a 3, the 8 and the 12 will cancel for a 2 and a 3, and then those 3's will cancel. So now I have a t squared and a t cubed, so that'll leave one t on the bottom. I have an s here and an s here, so actually there's two s's on the top, which will cancel the two s's on the bottom. One r on the top, get rid of one on the bottom, so on the top I'm left with a 2, and on the bottom an r and a t. Here we have an expression that involves division. You can't do any of our cross-canceling with division, so one way to combat that is to turn this into a multiplication problem. I can do that by multiplying by the reciprocal of the second fraction. So I take the fraction and flip it, and now I can just cancel things that are on the top with things that are on the bottom. 5 and 15 leaving a 3, 2 and 4 leaving a 2. I have two x's on top and one on the bottom goes away. One of the a's on top, leaving me an a squared on the bottom. All of the b's are gone, and it looks like one y, leaving a y squared on the bottom. So on the top a 2 and an x, on the bottom a 3, a squared, y squared. Here we have multiplication again. But now we have polynomial expressions, and before you start canceling things, you should factor each one of these expressions into their binomial factors. So we'll start by using the diamond here on the top, x plus 4 and x minus 2, two factors of negative 8 that add to be 2. Down here, x plus 3 and x plus 1, two factors of 3 that add to be 4. Up here I'm going to take out a 3, leaving an x plus 1, and the bottom doesn't factor at all, so x minus 2. Now I can cancel any factor on the top with any factor on the bottom because I'm multiplying. X minus 2 is a factor, that goes away. X plus 1's gone, so I'm left with 3 times x plus 4 on top over x plus 3. The other way you can write that is by distributing the 3 and making it 3x plus 12 over x plus 3. Either one of those is an acceptable answer. Here's another division problem with factoring that needs to be done. So I'm going to factor here a plus 4 and a minus 3 is how that trinomial factors. And then down here is a difference of squares, a plus 3, a minus 3. Now I need to rewrite the problem because currently it's division and I would like to make it multiplication. So I'm going to multiply by the reciprocal by putting the a plus 3, a minus 3 on top, and then moving the a plus 4, a minus 3 to the bottom. Now I can cancel factors, a minus 3's, a plus 3, so I'm left with a plus 2 over a plus 4. This example is called a complex fraction. And it's called that because the numerator and the denominator are both rational expressions. Now it looks really complicated, but with a little bit of rewriting, it's not too bad. This is really r squared over r squared minus 25s squared divided by r over 5s minus r. And so when we write it like this, it looks like problems that we've already done in the past. We're going to factor and then use the reciprocal. So r squared here, it looks like this is a difference of squares, r plus 5s and r minus 5s. And then I'm going to multiply by the reciprocal of 5s minus r over r. Now right now I have a 5s minus r and a r plus 5s. So those are pretty close, and if you remember a couple of slides back, we did this idea of taking out a negative 1. So I'm going to take this and pull out a negative 1, which is going to make the r positive and the 5s negative. So I'm going to rewrite the 5s minus r into r minus 5s with a negative 1 that comes out. Now I can cancel the r minus 5s's here. I can cancel one of the r's, and that's going to leave me a negative r over r plus 5s.